In an age of planetary exploration, NASA's Phoenix lander descended to the Martian surface.
30 meters. Touchdown signal detected.
It soon uncovered treasure: frozen water. The red planet had remnants of water buried beneath the surface. Earth was no longer the only terrestrial world with the key ingredient to life as we know it. Throughout history, we've observed our planetary neighbours in the sky.
Human beings have looked up to the stars as long as we've been able to.
Probes and landers have ventured to other terrestrial worlds: Mercury, Venus and Mars.
There were whole new areas in astrodynamics that had to be invented to be able to do this kind of thing.
Each journey revealed secrets of our solar system
We actually learned a lot about Earth by looking at other planets.
and brought us closer to the possibility of alien life.
There was more and more of this history of a watery pass of Mars in an environment that could have at one time even been suitable for life.
Every mission has paved another stone on our road to an off-world colony.
The moment we step foot on an alien world, we have forever changed it.
$4.6 billion years ago, our solar system was merely a giant cloud of gas and sprinkles of dust formed by ancient stars. But under the power of gravity, that cloud started collapsing, spinning ever faster and flattening into a disk.
Solar systems are pretty much always flat disks because when things rotate in space, they tend to flatten out.
A dense sphere of gas collected in the center. At its core, under the intense heat and pressure, hydrogen began undergoing a form of transmutation, nuclear fusion, releasing an explosion of energy that continues to this day. The sun was born. In this new solar system, small grains of dust began sticking together. Over 100 million years, a few grew massive enough that their own gravity crushed them into spheres.
The planets actually were just leftovers from the sun's formation. And slowly over time, they accumulated more and more material from the disk around the sun.
Our star's radiation blew away lighter gases like hydrogen and helium from the inner system. Ice was unable to form, and 4 rocky planets arose: Mercury, Venus, Earth, and Mars.
We talk about the terrestrial planets. These are the inner worlds, the rocky bodies.
While all started out with a similar evolutionary process, each reached a unique fate.
If you learn more about these terrestrial planets, you will learn more about our own history. And fundamentally, space exploration is about learning about ourselves.
The brightest planet in Earth's sky, Venus is our immediate neighbor in the solar system, at the closest possible distance of 38 million kilometers. The planet has shaped our understanding of our place amongst the universe. In the 1600s, Galileo Galilei observed Venus's phases, helping to confirm the Copernican notion that the planets orbited the Sun instead of the Earth. Humanity's comprehension of the solar system expanded over the centuries, but Venus's opaque cloud tops stirred speculation that habitable swamps or even oceans awaited below. answers seemed in reach, with development of the first robotic visitor to another planet. But any craft venturing beyond Earth's protective bubble would endure the dangers of interplanetary space.
A probe in space can be subjected to conditions which are far beyond anything we see on Earth. We're quite lucky in that Earth's atmosphere protects us from extreme temperatures or radiation from the sun.
The closer you get to the sun, the more radiation that you have. When there's a solar flare, if the sun does a bit of a hiccup, you can get really strong, powerful streams of charged particles that can actually knock out a spacecraft's electronics.
Designing probes for the space environment requires careful consideration of radiation, heat, pressure, and also temperature changes, because it's very easy to, within the life of a mission, experience very high shifts in temperature.
In the early 1960s, NASA began developing spacecraft to explore the solar system. The Mariner program consisted of 10 probes, launched over a decade, destined for the terrestrial planets.
Destruct command. Destruct command.
After Mariner 1 failed just 5 minutes after launch, hopes turned to its successor as our first emissary to Venus.
Mariner 2, a sophisticated unmanned spacecraft with orders to gather data on the planet Venus.
The second Mariner blasted off from Cape Canaveral on August 27, 1962. However, piloting a craft toward the center of our solar system came with a special challenge.
It's actually very difficult to get to the inner planets. A probe would gain so much kinetic energy. You need to be able to slow them down, or they just whiz right past.
So a spacecraft leaving the Earth's surface, relative to the Sun, it has very, very high velocity, and it's got to lose that velocity to be able to reach Venus.
Four months after leaving Earth, Mariner 2 passed Venus by, becoming our first interplanetary traveler.
Mariner 2 was the first successful flyby of anywhere in our solar system, making that journey past Venus for the very first time, looking at that cloud-covered world and getting a sense of the gases in its atmosphere.
Mariner 2 revealed a thick, crushing blanket, almost entirely composed of smothering carbon dioxide.
Venus is an inhospitable place. We wouldn't want to live there.
Sulfuric acid rains down from near hurricane speed winds, except it can't reach the surface because it's so hot.
Despite being a similar size to Earth, we had not found a twin, but a worst-case scenario of a runaway greenhouse, a buildup of heat-trapping gases that spiraled out of control.
Clouds trap heat, increasing levels of carbon dioxide from volcanoes, say. That heat in turn causes greater evaporation, more clouds.
It's now insulated and boiling at this huge temperature.
The accumulation of its thick atmosphere didn't just affect Venus's temperature and pressure. Mariner 2 confirmed that Venus spins on its axis opposite to the conventional direction of the other planets. But that may not always have been so.
We think that in the first couple of billion years after its formation, Venus was rotating in a similar way to the other planets. And then over the last few billion years, Venus has been slowing down, almost stopped, and then actually rotating in the opposite direction.
Venus's thicker atmosphere may be to blame. The Sun's gravitational influence could have pulled on it with enough force to cause the retrograde rotation.
All we know is that there is something very strange in the history of Venus. It has a very strange atmosphere, and perhaps the two are connected.
Hot on the trail of Mariner 2, the Soviets initiated the Venera program. The goal was not merely to pass Venus by, but to touch its surface.
All the while during the Cold War, where the US was aiming for the moon, the USSR was also sending missions to Venus. It's the real red planet, you might argue.
Early probes were crushed by the intense pressure before they even reached the planet's surface.
As the first missions started to go and get closer data, it became clear that Venus had an extremely challenging environment.
The next probe's parachute failed, but it reached the surface intact. Venera 7 made the first transmission from another planet's surface. The probe survived for 23 minutes before succumbing to heat and pressure.
The Venera program run by the USSR was an incredibly successful mission, actually, in terms of scientific exploration of our solar system.
The probe measured surface temperatures of 475 degrees Celsius, and scientists inferred an atmospheric pressure 91 times that of Earth's at sea level. 5 years later, in 1975, Venera 9 returned the first image from the surface of another planet. A single black and white photograph exposing a rather mundane, rocky surface.
It seemed to be an almost impossible task to be able to land probes on a surface of a world like that. But the Russians achieved it and sent back the first images of that world.
And once that mission had been successful, it was possible to design the future missions to adapt to what we now knew those surface conditions were.
The Soviets continued the Venera program into the 1980s, sending back ever more images and data.
Those images, even today, are helping us to form our understanding of that planet, even though we're only just looking at a few small areas.
Rather than focus on one small area of Venus, NASA's next mission sought to map nearly all of its surface. On May 4th, 1989, Magellan became the first deep space probe launched from a shuttle.
The advantages of launching a probe such as Magellan from the shuttle rather than from a conventional rocket are that you have a bit more control over how it sets off.
There are humans operating the shuttle, and they are able to safely check out the instrument before releasing it into space.
That allows you to really efficiently send the probe off without any difficult thrusting maneuvers or anything coming from the spacecraft itself.
We started the elevation procedures for the deploy. We went ahead and threw the switch and sent Magellan on its way.
4 months after leaving Earth, Magellan began transmitting radar images of the Venusian terrain.
Magellan spacecraft could use radar to penetrate through that blanket of cloud, to look at a surface that was totally alien. It was a world covered in volcanoes and areas of lava flows.
Mapping of Venus quickly showed that it's also active. Venus is volcanically active, it's seismically active. Processes are happening on the surface. Land is changing, land is forming.
Though some regions demonstrate geologic change and renewal, Venus's crust is hundreds of millions of years older than Earth's. Our neighboring alien world cannot recycle its rock the same way our planet does, through the movement of tectonic plates. Magellan revealed the possibility that within 2 billion years of its early history, Venus may once have been like Earth, with a liquid water ocean and habitable surface temperatures.
We think that Venus originally had an atmosphere similar to Earth, but over time, the water boiled off due to the sun's radiation, because Venus is closer to the sun than the Earth, so it receives more of the sun's light.
As the sun ages, its luminosity grows, shining an ever more powerful light on the Earth. Combined with humanity's addition of greenhouse gases into the atmosphere, our planet may one day reach a similar fate.
Potentially, our Earth could go the same way. So it really makes us think about how precious our environment is.
There is a mystery with the origins of Venus that we want to understand, if only to potentially save ourselves in the future. It really is the evil twin of our Earth, and that was only revealed because of these robotic missions.
The European Space Agency's Venus Express began orbiting the planet in 2006. One of the craft's more surprising discoveries was an uncharacteristically cold region high in the planet's atmosphere, where carbon dioxide could freeze into snow. Dipping to minus 175 degrees Celsius, atmospheric layers like these entice astrobiologists.
The atmosphere of Venus might be home to some kind of life. It's possible. It wouldn't be anything like we think about here.
As a world of so many extremes, a myriad of mysteries remain.
Venus will retain its mysteries for a little longer, I suspect, if only because it hides them so well.
Named for the Roman god of messengers, travelers, and thieves, Mercury is the smallest planet in our solar system. At an average distance of 77 million kilometers from Earth, Mercury is the innermost world.
Mercury is a tiny planet and very close to the sun. And the sun has a constant stream of very hot charged particles coming off it called the solar wind. And that actually stripped away Mercury's atmosphere a very long time ago. And it's actually creating a little helium atmosphere from the gases inside the rocks on the surface of the planet.
Mercury is a world of extreme temperatures, over 400 degrees Celsius during the day and negative 200 at night. Understanding this tiny world is a crucial piece in the puzzle of the terrestrial planets.
The world itself is remarkably dense.
Like Earth, Mercury's interior has layers. However, Mercury's core contains far more of the planet's mass, 85% compared to Earth's 55%.
If you think about what's underneath the ground of the Earth or Venus or Mars, if you strip away the atmosphere and the stuff on it, this is probably the core of what a planet looks like.
It gives us a handle, a way to try to wind the clock back to those earliest days of our solar system, and that's why we're so fascinated by it.
Launched on November 3rd, 1973, Mariner 10 was the last spacecraft of the program, but the first ever probe destined for Mercury.
You've got a means of getting a tremendous amount of information that is beyond imagination at the present point in time.
The energy costs to sink so deep into the gravitational well of the sun as Mercury resides is more costly than to go the other way to the outer worlds.
There were whole new areas in astrodynamics that had to be invented, to be able to do this kind of thing.
In order to reach Mercury, Mariner 10 was the first spacecraft to employ an interplanetary slingshot maneuver. Flying first by Venus, it used the planet's gravity to decrease the size of its arc around the sun, bending its flight path toward its target.
You have to do your rocket burns at exactly the right time. You have to alter your orbit in exactly the right amount. You have to do course correction, otherwise you can just miss.
An error of only 1 mile at Venus, if not corrected, could result in a 1,000-mile error at Mercury.
Approaching Mercury, Mariner 10 began transmitting photographs of a world pocked with massive craters, revealing more clues to the formation of our solar system.
We think that these massive craters are evidence of early bombardment. So there was a period right after the solar system formed where there was a huge amount of massive asteroids and comets which bombarded the planets.
Mariner 10 was the first spacecraft to return to its target, rendezvousing with Mercury 2 more times.
To be able to fly past the planet not once, twice, 3 times, it actually helped us learn a lot more about this gravitational slingshot maneuver, which is essential to all of the missions that we use today across the solar system. So Mariner 10 was the cornerstone of every single mission that we fly today.
Across its 3 encounters, Mariner 10 returned over 2,700 pictures of Mercury, revealing nearly half the planet's surface. Since March 1975, the spacecraft has slept soundly, still in orbit around the Sun. The next mission to the innermost world would take decades of preparation.
2, 1, and liftoff of Messenger on NASA's mission to Mercury, a planetary enigma in our inner solar system.
After a 7.9 billion kilometer journey lasting 6 years, Messenger entered Mercury's orbit in 2011.
Messenger was the first chance to actually put a spacecraft into long-term orbit around the planet Mercury, to truly map its surface.
The probe had to circle the Sun 15 times before it reached the exact speed and position to be captured by Mercury's gravity.
We got a whole world view of this planet, particularly the polar regions of Mercury, areas where there are craters that have been in shadow for billions of years.
We're seeing all kinds of evidence for volcanism, the tectonic deformation of these plains, ghost craters, which are pre-existing impact craters that were later covered over by lava.
The striking images of the planet's surface helped confirm a theory that Mercury is actually shrinking.
What we're talking about here is a phenomenon in the late stage of the evolution of planets. Planets were very hot in the early history of the solar system, and most of that heat still has a residue in the interior of the planets.
As Mercury's interior cools, shedding the heat generated during its initial formation, the surface is pulled inward, causing the planet to shrink.
The surface is scarred, and we see those cracks and fault lines as the ground beneath the crust shrinks. This is a bizarre world, and one that is very much worthy of our attention.
Messenger's mission came to a dramatic end in 2015.
We'd like to end a mission in the most useful scientific way.
When the Messenger spacecraft ran out of fuel, it was sent on a final experiment, and that experiment was to basically self-immolate on the surface of Mercury.
While we could study Mercury from orbit and we could make some educated guesses about the density of the surface, best way to do that is to smash your spacecraft into it.
Closing in on the Mercurian surface, Messenger was able to collect data on the magnetic anomalies in the crust and ice hiding in the shadowed craters near the planet's poles. Mercury will not be alone for long. Launched in 2018, the joint European-Japanese mission, Bepi Colombo, has been spiraling toward the innermost planet.
The missions are designed to be as wide open in terms of their capabilities as possible, because we simply don't know the right questions to be asking of worlds that are as unknown as Mercury and Venus. That's what makes the exploration fun.
Mars, a world half Earth size, hangs as a red speck in our night sky. The outermost terrestrial planet, Mars's orbit lies 78 million kilometers beyond Earth's. As telescope technology improved in the 19th century, observers began to record fascinating shapes on the Martian surface. The sketches of Italian astronomer Giovanni Schiaparelli hinted at extraterrestrial architects.
In the late 1800s, Schiaparelli made observations of Mars and drew maps of its surface. And some of the features that he saw, he labelled canali, meaning channels in Italian.
This created great excitement that we might actually have neighbours, you know. We might go to Mars and there would be other beings that we could talk to.
In the 1960s, probes to the red planet sought to separate fact from science fiction. The fourth probe of the Mariner program became Mars's first visitor. Over a few hours, Mariner 4 captured 21 complete images and a partial 22nd. But each would take nearly 9 hours to transmit back to Earth.
Hey, there she goes. Yeah. That's data.
They had to wait so long for such a small amount of data.
The figures cascade to the Earth. 240,000 bits of binary code, representing 40,000 dots that will finally make up the first picture.
They're waiting so long that they, in fact, started to color in the pictures with pastels because to actually process that data would take even longer and they just couldn't wait.
The images did not reveal a world of extraterrestrial canals.
When Mariner 4 gave us the flyby images of Mars, it revealed a desolate landscape.
They saw dry rocks and craters and dust, and this is not at all what they expected.
And I think that may have been disappointing to the community at the time. We took for granted that the variation we see on the Earth would be found elsewhere, not realizing how unique water, and in particular life, is.
However, Mariner 4's pictures were snapped in a momentary flyby. A prolonged trip to Mars might reveal more. The penultimate Mariner mission would confirm whether or not Mars was truly uninhabitable. The Mariner 9 probe launched in May 1971.
Mariner's rocket engine will be fired for 15 minutes, slowing it by 3,500 miles per hour so it can go into orbit.
Mariner 9 became the first spacecraft to orbit another planet. The probe's instruments began to unveil the planet we know today.
In nearly a year of operation, 2 television cameras transmit more than 7,000 photographs to ensure that the entire Martian surface will be mapped.
An extraordinary world. 2 halves, the northern hemisphere almost perfectly flat, southern hemisphere heavily cratered, pockmarked highland regions, mountains, and sort of in between them is this anomaly, what we call the Tharsis Rise. It is an area where there was clearly huge amounts of volcanism in Mars's early history.
An enormous rift valley, almost 3,000 miles long. An astounding feature which no one expected on Mars.
Mars has the highest mountain in the solar system, Olympus Mons, a giant volcano. It has dust storms, it has weather in its thin atmosphere, so it really is a very active world.
We have fossilized riverbeds. There are mineral deposits that could only have formed in seas and lakes. We have features that reveal global oceans. Mars has revealed itself to be a world with a past, at least, that was water-rich.
Mariner 9 provided the first clues that waters once flowed on Mars. Humanity's first close-up examination of Mars would be facilitated by two identical craft, the Viking landers.
They were designed to learn as much as we could about the surface of Mars, given the technology that was available.
A small shovel on the end of a telescoping arm will scoop up some Martian soil, then drop it into a chemical analyzer on the Viking landing craft.
Vikings 1 and 2 would touch down on opposite sides of the globe.
The first photo from the Viking mission was actually of the lander's foot. That's a really interesting first image to see because it gives you scientific information as well about what the surface is like.
Look at the beautiful rock. Fantastic.
In addition to collecting photographs and measurements of the surface, the Viking landers dedicated 3 experiments toward the search for life.
The Viking spacecraft were looking to see whether there was any evidence, for example, of methanogenic microbes on Mars, microbes that would emit methane.
Were there Martians? Was there some kind of life somewhere at the surface or below the surface of that world?
Scientists concluded that the makeup of Mars's soil, coupled with solar ultraviolet radiation, restricted the formation of living organisms. But Viking's findings didn't exclude the possibility that an ancient Mars once supported life.
So we don't know really where we are in the evolutionary cycle, and of course that's part of what we're trying to find out.
With the Viking missions in the 70s, they were simple landers sitting down on 2 different spots. But if you really want to explore, you need that mobility. So we had a small little rover called Sojourner, which landed with the Pathfinder mission in 1997. It showed that we could operate a small automated vehicle on the surface of Mars, but again, it couldn't go very far afield. So they decided to build 2 rovers with the lander and the rover as one vehicle.
The Mars exploration rovers were twin solar-powered robots designed to hunt for evidence that ancient Mars once held water.
They were equipped with an entire laboratory to measure the mineral content and other properties of samples that they were able to collect.
It was just transformative with having that ability to be able to just have an automated human being going around the planet.
Getting a bounce signal. We're getting a bounce signal. We're getting a bounce.
Spirit landed in a crater which certainly showed signs of being once filled with water, but sometime in the intervening history of Mars had been covered over by a layer of lava. So Spirit had to go on a much longer journey, travelling several kilometres to reach some mountains. And literally, the moment they got out of the lava field, they found what they coined the pot of gold. Evidence that there was water in this spot billions of years ago.
Spirit found rocks rich in iron and magnesium, which could only form when Mars was wet and warm. Spirit's twin successfully landed on the other side of the planet.
The Opportunity rover, she landed in a small crater, the ultimate hole-in-one. And right in front of that rover was direct evidence that there was sedimentary layered rock, materials that can only form in the presence of long-standing water.
The puzzle pieces have been falling into place. We have concluded that the rocks here were once soaked in liquid water.
Spirit, she had to struggle for everything to achieve the goal of finding out the water history of Mars. For Opportunity, it was all laid out in front of her.
Originally slated for a 90-day mission, Spirit lasted over 6 years. Opportunity kept going for another 9 after that, traveling a total of 45 kilometers, further than any off-world rover.
Opportunity made us Martians. There's been a team of people that go to work operating the rover, and the surface of Mars has now become our neighborhood.
Mars can be both cruel and kind. They thought dust building up on the solar panels would eventually block the sunlight, and that would be the end of their mission. But those whirlwinds on Mars blew the dust away, kept the solar panels clean, allowed the rovers to drive further, to continue doing more science.
However, in 2018, a planet-wide dust storm sealed Opportunity's fate.
This dust storm, it was really sad. It actually was so huge it covered the entire planet. And then it lasted so long that Opportunity didn't have any power left.
The rest of the instruments were working fine, but if you don't have power, you can't do much else.
The last message from rover Opportunity was a message from the engineering instruments on board. And effectively it was, my battery is getting low and it's getting dark. And 15 years of operations on the surface of the red planet finally came to an end.
This concludes operations for MER-1 spacecraft ID 253.
Sad day for all of us.
MER project off the net.
Even without our rovers, humanity still had a close eye on the red planet. NASA designed the Mars Reconnaissance Orbiter, or MRO, as a next-generation eye in the sky, capturing surface features as small as a meter. It carried a novel telecommunication system that other Martian missions could use for a navigational aid. Since its arrival in March 2006, the MRO has circled the planet more than 60,000 times and sent back more data than all Mars missions combined. Its powerful camera has mapped 99% of the surface in unprecedented detail, revealing a planet that is still active and changing.
The reason we know a lot about Earth is our satellites. We can measure what happens as a planet as a whole, how it changes over time. And that's what Mars Reconnaissance Orbiter has been doing for Mars. It's been measuring changes over the planet as a whole.
Having a vehicle orbiting around Mars like the Mars Reconnaissance Orbiter with its high-resolution cameras has revealed the planet as an entire world with a diverse geology. And in some ways, it's actually got better maps of the planet Mars than we currently have for the Earth.
The MRO identified places of interest to send future landers and rovers, continuing the hunt for Martian water.
While there was very clear evidence of there being water once on the surface of Mars, we'd never really had a chance to get down there and dig it up and taste it with the instruments of a spacecraft. The Phoenix mission was landed near the northern polar regions of the Red Planet and had a digger on board.
Touchdown signal detected.
And just 6 centimeters below the surface, it came across this bright white material.
The rovers have been investigating the history of past water on the planet Mars for almost 5 years now. Phoenix is the first mission to actually touch that Martian water.
We tasted for the very first time the waters of Mars.
Water is fundamental to human life. Knowing where the water on Mars is, how much there is, and how to access it is critically important for any potential future missions.
While water is an essential ingredient to life as we know it, our robotic Martian spies have detected a chemical often created by life: methane.
The probes that we've sent there have not yet found definitive evidence of life, but there have been some close calls. There have been some signals that potentially complex organic chemicals might be there.
We have tantalizing hints of methane on Mars, and why that's important is, at least on Earth, methane is produced by living organisms. We call it a biosignature. It's entirely possible this could be geological in origin, but we may have found those first clues of life itself beyond the Earth.
The hunt for life and other mysteries Mars still holds will continue with future missions.
Where did the water go? Did it support life? Could it support life? Mars is a great example of all these big questions we have about the universe on our doorstep. And because it's on our doorstep, we can explore it more. And as we explore it more, like everything good in science, more questions arise.
We continue to probe Mars's past, hoping to understand its transformation from a primordial watery world. Our star bears some of that responsibility. In order to comprehend the mechanics of the inner planets, we need to unlock the secrets that drive the solar system. We need to study the sun.
The sun creates all the heat and light in the solar system that enables all life on Earth to exist. It's also created very extreme environments in the other terrestrial planets.
Prevented life in Mercury by stripping away its atmosphere. It prevented life on Venus by causing the evaporation of all the water and turning it into a runaway greenhouse.
Our sun produces its own weather, matter and light streaming out, influencing every orbiting body to some degree. Every so often, intense flares rise above the surface, ejecting charged particles up to 3 million meters per second. Sometimes these ejections collide with the Earth.
When you see those beautiful aurora, the northern lights or the southern lights, that is caused by solar storms, stuff leaving the sun, hitting our Earth's magnetic field, rubbing it around. Now that's great, pretty pictures, but it also creates radio interference. It creates problems here on Earth.
The surge creates a geomagnetic storm, which heats up portions of the atmosphere and applies drag to satellites. It interferes with navigational systems and induces harmful electric currents in power grids.
So if we want to predict that solar weather, we need to understand how it originates, and we have to get up close and personal with it.
Space-based missions have been trained on the sun for decades. But until recently, they've all kept their distance.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
Launched in 2018, the Parker Solar Probe will arrive within 6.2 million kilometers of the Sun's photosphere, what we describe as the surface.
The Parker Solar Probe is ambitious because it's going to get just so close to the Sun. And as you can imagine, that's going to be quite a hot place to be. And also, there's going to be a lot of radiation from the solar wind as well.
Beyond the Earth's magnetic field, which directs most of the solar wind away from us, The Parker Solar Probe's instruments will have a shield of their own. 2 plates of carbon encasing a core of carbon foam. On one side, temperatures will reach up to 1,400 degrees Celsius. But behind the shield, the bulk of the spacecraft will rest at a comfortable 30 degrees.
The ability of that spacecraft to survive the journey, for its instrumentation to work, and to deal with that input of thermal energy from the front side, from the sun, it is quite astonishing.
The sun's temperature is one of the peculiar puzzles we seek to solve.
There's a big mystery. You go to the sun, the surface is 6,000 degrees Celsius. Move away, the temperature doesn't go down as you might expect. The temperature goes up, and it goes up dramatically to 2 million degrees Celsius. How the sun is actually doing that, we've got lots of theories, but the Parker Solar Probe will help us test those theories.
It's really important for us to gain a greater understanding of the solar activity and to monitor it. It'd be great if we could model it.
The sun is the engine of our solar system. The Parker Solar Probe is going to help us understand a lot more about that engine, how it actually works. We'll get to lift the hood of the vehicle for the first time.
Humanity has long aspired to become a star-faring species, and the terrestrial planets may one day open a gateway to the universe. Mars is the closest within reach, but the challenges are many.
While it takes a few days to get to the moon, Mars is a completely different kettle of fish.
A one-way trip to Mars would be roughly half a year, but a mission that brought humans back home would last 2 years.
The biggest hurdle to start with is how do we get people to Mars, never mind getting them on the surface.
Those technical challenges are certainly huge, that's for sure, but we have a pretty good history of overcoming that sort of thing. The biggest challenges are going to be the human challenges.
Getting there emotionally healthy, physically healthy, that will be a major stepping stone.
The communication delays would be considerable. The delays in getting medical help would be considerable. So those colonies would have to be very much self-sufficient.
Crewed exploration will require well-planned infrastructure already in place.
We need to be thinking about self-sustainable missions and the utilization of resources in situ, things like fuels, water from the planet, and using those to create the things that we need to survive.
It turns out that Mars is not an easy place for humans to live on.
If we were living on Mars, we'd actually have to live underground, because in addition to the massive storms that exist and the cold temperatures, there is no ozone layer. The sun's rays come straight in, and that would cause cancers and other terrible problems in humans.
It has all kinds of hazards to do with radiation, as well as the fact that its atmospheric pressure is only about 1% of the Earth's. Its temperature is very low. It would not be an easy place for humans to make a home.
Laying the first boot prints on Mars will require our brightest minds.
There's some amazing innovation that needs to be done by solving this for things like the lunar mission. There's all this translatable devices and technology and know-how that benefits us back on Earth. We always get benefits by doing this kind of new innovation and not being scared by these big challenges.
Before we set foot beyond our Earth, we must answer a fundamental question. Are these worlds meant for us?
I think it's a fantastic philosophical discussion right now. We can colonize Mars at some point in the future. Whether we should or how do we do that appropriately?
I believe that humanity has the duty to explore. And with that comes a duty of care to the places that we travel.
For all we know, Mars might actually have living organisms on it. Until we could say with certainty that Mars was completely sterile. We need to be very careful how we treat Mars and not just look at it as a place where humans can take over.
We should step lightly. The moment we step foot on an alien world, we have forever changed it.
Unlocking the secrets of the inner planets, humankind learns more about our home.
We look at Mars and we look at Venus, our neighbors. In a lot of ways, they are very similar to different times of the Earth. And that will give us clues onto our own history and our own destination.
Though the past century of exploration has revealed much, we must continue pushing the boundaries.
Explorers is who we are as human beings. We all do it from the moment we're born to the moment we die. Without exploration, we don't advance as a civilization.
The question is not if we will venture to these worlds, but when.
It's in our nature to explore and to understand and to investigate and to be inspired by doing so.